Hello everyone, my name is Arohi and welcome to my channel. So guys, Meta have released a new object segmentation model called Segment Anything Model 2 or SAM2. This model can segment anything from the images and videos. So in image segmentation task, this SAM2 model is more accurate and 6 times faster than the Segment Anything model. So today we'll try to understand the SAM2 model, the paper of SAM2 model, and then we will see how to run this model on a local machine. I'll show you how to set up the environment on your local machine and then how to run the code of SAM2 which is provided in this official GitHub repo of Meta. So let's open the paper first. This is the paper of SAM2. Today we will try to understand this paper. So let's see this figure. This is the model architecture of SAM2. First, here we are providing the frames of the videos to the image encoder. So videos are a collection of frames, and whenever we want to perform any computer vision task, first step is to fetch the frames one by one. Then we perform whatever task we want to perform on them, right? So for example, when we want to perform object detection, we read frames one by one and then we detect object from those frames. So in the same way, SAM model performs segmentation on each frame one by one. So first step is image encoder. So image encoder will take the frames and then it will convert them into feature embeddings. So this image encoder step will be performed only once for the entire video. And the image encoder which is used over here is MAE, masked autoencoder. So after that, the second step is this memory attention. So guys, this step is only needed when you are working with the videos, means when you are segmenting objects from the videos. So when you are segmenting objects in images, SAM2 model will work like SAM model only, which is the mask decoder. This mask decoder will take the feature embeddings from the image encoder and will predict a mask. In SAM, the model which was released last year, there each frame is treated independently without considering what was detected or predicted in the prior frames. Okay. But in SAM2, which is an enhanced model, the approach to work with videos have been modified. Here they have implemented the concept of memory, which stores the information from previous frames and the prompted frames. See, in this image only you can see this memory attention, memory encoder, memory bank. We will understand all these things in details one by one. So here just understand this thing, that to handle the videos they have introduced these concepts: memory attention, memory encoder and the memory bank. And why they have introduced these memory related concepts? Because they want to store the information from the previous frames and the prompted frames. Now let's understand what are previous frames and what are prompted frames. Information from previous frame means objects that have been previously identified or segmented, and this helps the model to understand that what have been detected in the past, and it will maintain the consistency across the frames. Okay, so this is what we need previous frames information for. Now let's talk about prompted frames. So these are the frames where the user provide additional input or prompts to refine the segmentation. Let's understand it with this example in this figure 2. In this first frame, you'll see that we have three red marks, dots, and one green dot. And the green dot means we want to put the mask on the object where this green dot is, and this red dots means that we are not interested in this object, we don't want to put mask on it. So this is a positive label and these are the negative labels. Red ones are the negative labels. So in the next frame here, you'll see that we only have a mask on the tongue because the green point was on it. In the third frame, we are not getting the mask on the tongue. So we will perform the refining step. Refining step means we will again provide the additional input, point over here, and we are telling here that this is the tongue, this is the object we are interested in, so put a mask on it. So this is the prompted frame. Previous frames means this first frame and the second frame are the previous frames, and the prompted frame means where we are performing the refining step. and this is the fourth frame, and here you can see our model is again able to put the mask on the frames. So this is what previous frame and prompted frame is. Now let me show you another example for this. Here in this image you will see the person on the left side. So in first two frame it is getting segmented, but in third frame it is not getting segmented, right? So when the model is performing segmentation in the third frame, at that time the mask of the first two frames were in a memory, and the prompted frame is the current frame, the third frame. Over here we are refining the segmentation by providing the additional input, which is this point in this case. Then the person is getting tracked, the person is getting segmented in the next frames. So guys, we'll see this process with the help of coding in some time. I'll show you how the entire function works step by step. So now we know, let's go back to the same image. So here guys, before understanding the concept in more detail about memory attention and about this prompt encoder, mask decoder, and this memory encoder, let's understand memory bank first, and then we will move backwards and we'll understand these things. So SAM2 model maintains memory bank that store embeddings from previous frames and predictions. So this bank is continuously updated as the new frames are processed, right? So when first frame will go, the data related to that will be stored over here, and then the second frame, and then the third frame. So on the basis of the frames processed, this memory bank will keep on storing the information. Every time when new frame is processed, SAM2 model does not rely solely on the raw features which are extracted from here. Instead, it adjusts these features based on the information which it gets from the memory bank. See, memory bank, and we are having an arrow over here. That means from the memory bank, SAM2 model is getting the segmented mask from the previous frames, and then on the basis of that it is adjusting the current frames and also the prompted frames. So with this, by considering the past predictions and the user's inputs, SAM2 model can maintain consistency in object segmentation across various frames. For example, so if object was identified in previous frame, then SAM2 model can use this information to improve the segmentation accuracy and the stability in subsequent frames. Now let's see what exactly memory attention is doing. Once the model gets feature embeddings from the image encoder, these embeddings are further processed through memory attention mechanism. And the role of memory attention is to integrate the context from the previous frames into the current feature embeddings. And from where it is getting the previous frames? From the memory bank. Now let's see what code or model architecture is getting used here. So SAM2 model is built on transformers architecture, and let's see how this transformer architecture is getting used in this memory attention task. So guys, here we are using different transformer blocks and two different operations are getting performed here. The first one is self attention and the second one is cross attention. So the process of this memory attention starts with the self attention operation. Here each transformer block will perform self attention on the current frame's feature embeddings to capture the dependencies within the frame. In self attention, what we are doing? We are capturing the dependencies within the frames, okay? And then we have cross attention. Here the current frame features are conditioned on memories stored in the memory bank. So this task here we are using two frames. First one is the frames from the memory bank, right? The past frames, which includes the features and the segmentation predictions from the past frames. And then we have a prompted frame. Prompted frames means the frame where additional user input is provided, like in this example. So these are the previous frames and this is the prompted frame. In this prompted frame, we have added the additional information that this is a person. We don't want to detect only shirt, we want to detect the person. So this is the prompted frame. So this part we are doing in the cross attention attention. After that we are having a multi-layer perceptron. So after the attention operations, the embeddings are passed through this MLP, which helps in refining and integrating the information further. So this step ensures that the segmentation masks are accurate and consistent across the frames. Then we have this prompt encoder. So guys, this prompt encoder is exactly the same prompt encoder which we have in SAM model. So it accepts the input in the form of box, points and mask. Let me show you over here. Here in this image you will see a star on the laptop. So this is the input image. So from this image I only want to put the mask on the laptop. So we can provide this in a prompt encoder. We can tell the X and the Y coordinate, and at this location we want to put the mask on. So this kind of information you can provide using the prompt encoder, or you can provide the box coordinates like in this over here. So when you will provide the box coordinates, and then the model will put the segmentation mask only on that area where that box is. And the third one is mask. So you can also provide the mask as input to the prompt encoder, and on the basis of these prompts your mask decoder will provide you the output. What is the output over here? The mask. Here you can see we only want to put the mask in this area, so that's what mask decoder is doing. It will show you the output, the segmented mask. Then we have this memory encoder. Now let's understand memory encoder. So the output of the mask decoder will become the input to the memory encoder. Then this memory encoder will combine the output of the mask decoder with the feature embedding of that frame, right? For every frame, the feature embedding and the output of the mask decoder is getting combined over here in memory encoder. And why we are doing that? Why we are combining it? Because this step integrates the current predictions with the original frame's detailed features. So this step ensures that the memory include both the current prediction, which is the segmented mask, and the detailed feature of that feature. So because of this step only, we can see that what the captured objects look like and where they are located in the frame. This combined information is then downsampled using convolutional layer, and downsampling will reduce the spatial resolution, which will make the data more manageable and focused on the more important features, right? Then we have a memory bank. In this memory bank, we'll store the data which we got from this memory encoder. We are storing it over here. Two things are getting stored in this memory bank. First one is spatial feature maps, and the second one is object pointers. Spatial feature map means detailed spatial embeddings of past frames representing the feature maps of each frame, right? And the object pointers are the vectors that carry semantic information about the object segmented in previous frames. This is what introduced in SAM2 to handle video segmentation part. Another thing is they also have introduced a new dataset. Let me show you that dataset. So this is the dataset, SAV dataset. The dataset used to train SAM2 is this SAV dataset. This dataset consists of 51,000 videos, and it is the largest video segmentation data till date. So you can see this data. Just scroll down, these many videos. You can know more about the data over here. And guys, here you'll see that there are no class labels for the videos or the mask annotations. So this means SAM2 model can identify and mask the objects, but it won't tell you what those objects are. For example, in this scenario where person and laptops are masked, they are not getting class labels. We are getting the mask, but we are not getting the class names for this. So we can write a logic for this, and we can work on this part. I'll show you that in my upcoming videos. This is what introduced in SAM2 model. Now let's open the official repo of SAM2. So this is the official repo. Here they have mentioned the steps to use SAM2 to install SAM2, but using these steps I was getting some errors. So let me show you the steps which I have executed to set up the SAM2 on my local machine. So I have executed this code in Anaconda. So let me open an Anaconda prompt. So guys, here we will create a separate environment because it is always a best practice to work in a separate environment whenever you are trying something new. So this is the separate environment. This is how I created a separate environment. Conda create -n. This is the name of the environment, and I want to have this environment using Python 3.12. So first you'll execute this command. I'm not executing it because I have already performed this step. Once you create this environment, next step is to activate the environment, and to activate the environment you will write this conda activate and then the environment name. Now the environment is ready. Next step is to clone the GitHub repo of segment anything model 2, so which is this. So for that let me enter in a drive, and I want to work in E drive, and here you can create a separate folder where you want to work. So I already have that folder, so I'm just opening that folder, this, and let me show you this folder. See, this is the folder. In E drive I have created this folder, and in this folder this is the cloned repo. And how I got this cloned repo? So now let me show you how to get this cloned repo. You can simply write this git clone and this, and after executing this command you will have a folder in your current working directory. Okay, this folder. Now open this folder. Here you will see various different folders and files. Next step is to cd to that folder. Right now guys, once you cd to this folder, so here they have mentioned to install it like this, but I was getting error with this command, installed like this Python this command. So I have mentioned all these commands in the description section. You can get these commands from there, and you can run using these commands, or you can also try working with these commands first. If these commands work with you, you can install it like this, or you can use the commands which I have mentioned in the description section. Now guys, the next step is to download the checkpoints, because what we want is we want to use the pre-trained model. So that means we will download those weights from somewhere. We will download those checkpoints and then we'll use it. So under this getting started, in this download checkpoints, there are two things. If you want to download any specific model, so there are different variants of this model, SAM2 model. So if you want to use any specific one, then you can download it from here. Otherwise you will see a checkpoints folder here, checkpoints folder. Inside that you will have this file. So this I got when I downloaded the checkpoints by running this script, but initially you will have only this file, and if you double click on it, you will get all these models checkpoints over here. So now you have downloaded the checkpoints. Next step is, see here they have also mentioned that if you want to use this model on a Jupyter notebook, then you need to install this also. So again with this command I was facing few errors, so I executed this command. Okay, this one. So you can try with this command, or you can try with the command which they have mentioned over here. And once you've done that, now everything is set up. Now you can execute the code. So now we are going to open a Jupyter notebook, and we are going to see how this code is working. So let's open a Jupyter notebook. So from here, first I'm showing you how to work with the images, then I'll show you how to work with the videos. So let's open it. First we are importing all the required modules. So guys, in this cell, second cell, we have some helper functions. So we are going to use these helper functions, and sometime I'll explain you these functions over there. Then here we are reading an image. So I want to work on this image which is present in this images folder, and then I'm displaying you the image. So this is the image. On this image I want to perform the segmentation using SAM2. Now First, see guys, there are different ways. There are 3 different ways to put mask on. First one is automatically generate mask. Second thing is you can put mask on the images, and the third thing is you can put mask on the frames of the videos. First I'm showing you how to use this automatic mask generator. So we are importing these different modules from the SAM2, and then here we are writing the model which we want to use. So here I'm writing that I want to use the large model, and this is the configuration file, and here build SAM2. So we are providing the configuration file over here, we are providing the checkpoint over here. I want to run it on a GPU, so that's what I've written. And then using this SAM2 automatic mask generator, we are saying that we want to use this SAM automatic mask generator with this model, and then we are passing, in the next line we are passing the image to it, the image, this image, and you'll see we are getting mask on each and every object which is present in this image. So this is what this automatic mask generator does. So whenever you want to put mask on everything which is there in the image, then you will use this automatic mask generator. Now the next thing is, let's say you don't want to put the mask on all the objects, you only want to put the mask on this laptop or on this person. Then how to do that? So for that, these are the other modules, but here we are importing this SAM2 image predictor, and here you will define the checkpoint which you want to use for that task, and we are building the SAM model by providing this checkpoint and configuration file. And then here SAM2 image predictor, we want to build this predictor using which model? The model with the configurations which we have defined over here. And then predictor dot set image, by using this set image you will provide the image. So our image is this image, right? This is the part which will tell your model that where to put mask on. As I've told you that we want to put the mask on the laptops. So this is the X value and this is the Y value, and we will provide this value to our model, and our model will only put the mask on the object where this point is. And this class label 1 means that this is a positive class, this is a foreground class, the interested class on which we want to put the mask. And if it is 0 means this is a negative class, we don't want to put the mask on it. So whenever you want to put the mask at particular location, at particular point, you will provide this label 1 with that input point. Okay, so this is the point. Now we are displaying this input point and input label on that image. See, you can see here. So this is the point. So X value and a Y value, we need 2 values, with that we are getting this point. So now we have a point on the object which we want to segment. Next step is this. So guys, remember the first step is image encoder will create a feature embedding. So that's what we are doing over here. After that, in this cell here, predictor dot predict, we are providing the input point which is the laptop, input label is 1 and the multi-mask output is true. So guys, over here our model will provide us 3 different outputs with a mask on the laptop, and then what we can do is we can pick the one with the highest score and then we can make it a final output. Okay, so here I'm just checking the mask shape and using this show mask function. So guys, this is the helper function which we have defined above, and here with the help of this function you can see this is the first mask, this is the second mask, and this is the third mask. So out of these, over here the score is 64, 73, and the first one score is 96. So now out of these 3 scores, this one is the best, so we can keep it. How to do that? So for that you will use this logits np.argmax, and with the help of this you will only get the result with the highest value. So here we are only getting the output out of those 3 outputs where the laptop is being segmented more properly. So this is how you can work with points. Now let's say you don't want to give the point like this, you want to provide the box around the object, and you want to send that bounding box coordinate to the box coordinate to the model, and you want that model should put the mask on the object which is there in that box. So how to do that? So for that, again, we are providing 4 values. So these are the 4 bounding box coordinates, and here we are calling the predictor dot predict. We have provided this input box over here, the values, the box values. Predictor, what we have in predictor, our model, and we want to predict, and we want to predict using these things. And here we have provided the box value. This will be the input to your prompt encoder. Okay, and then with the help of show mask we are seeing the output. Here our model is only providing us the mask for the object which is there in this bounding box. So this is how you can work with images. Now let me show you how to work with the video. So for that we have this Jupyter notebook video mask. Let me open it. So here, so first I'm writing a function. This function is responsible to fetch the frames and to store those frames in a folder. So remember, in this figure only, here we can see that the input to the image encoder will be the frames of the video. So we first need to fetch the frames of the video. So for that we have written this function. First let me show you the video on which we are working. So the video is here in this images folder. So this is the video on which we are working. Okay, so this is the video, and the frames of this video I have stored in this frames folder. So these are the different frames of that video, and we have total 21 frames. So these frames we are getting in this folder with the help of this function, extract frame function, right? Next thing is we are importing all the required modules, and here we are loading the checkpoints of the model which we want to use to perform the functionality on the this video segmentation. So this is the checkpoint we want to use. Here we are building the video predictor. So this time we are importing this. For the video predictor you'll import this, and then you will provide the model configuration and the model checkpoints, and this show mask and the show points, these are the 2 helper function. With the help of this show points function, will show the point on the object which we want to segment, and with the help of show mask we'll put the mask on that person, on that object. So this is the path where our frames are stored. So as I've told you, frames folder, I have a frames folder. In this frames folder I have all the frames. So here you will write the path of the folder where frames are stored, and here I'm just fetching the frame and I'm just displaying one frame over here. So this is the frame, 0th frame. Okay, and then after that, guys, this line inference state, for that we are using this predictor dot init state, and what it does is it will store all the frames of the video in this video path. Okay, and then here now the task start. The first thing is, as I've shown you this frame, suppose in my video I only want to put the mask on the person, this one, the person who is on left side. So for that we need to put a point over here on this person somewhere. So that's what we are going to do. So we are writing frame index is 0, that on the 0th index we want to start the work from the 0th index. Object ID is 1. So for every object there will be a different ID. So for this object, the person who is on left side, I've given him a ID 1, and these are the points. Here I have mentioned the points. Okay, this is the X value and this is the Y value, and then you will provide the labels also, and the label is 1. So guys, remember I've told you that for the positive points you will give 1 as a label, and for negative point, the area where you are not interested in, where you don't want to put the mask, there you will give the 0. Okay, label. So this is the label. Predictor dot add new points. Now this add new points is a API. Using this API we are providing all this information to our model, and here object ID we have defined here, frame index is 0, and then points we have defined here, and the labels we have defined here. Now we are just plotting it. Here you can see. So this is the point, the value which we have mentioned on x and y. This value is putting a point over here, and then our model is only displaying the mask on the person where the point is. Okay, and then now let's see the next frames, if the person is getting segmented properly or not in all the 21 frames of the video. So over here I'm just displaying a random number on the 12th frame. Now let's see what is the result on the 12th frame. All the other things are same, just the frame index is different, because we want to see if the same person is getting segmented over there or not. So in the 12th frame also the person is getting segmented. Now here this time I want to check if the person is getting segmented in 16th frame or not. So rest of the other values are same, but here you will see that person is not getting segmented, only the shirt is getting segmented. Now we will write the refining step. Remember over here guys, in this code if you'll see, now we are going to perform this step. We are going to mention the points again to refine this process. So let's do that. Okay, so it's here. So on the frame number 16th, ID is 1 only because we are working on the same person. Here, this is the previous point. So guys, previous points will be there, and additionally you will add the new point now. So here I'm adding this new point, and it is there in points only, and again we are displaying it. Let's see. See, this was the previous point, and this is the new point which I added. When we added this new point, after that you can see that now the person which is on the left is getting segmented again. So guys, this is how you refine the process, but always remember that the previous points will be there and you'll add the new points with it, like this. So guys, this is how you can use SAM2 model. So this code, I'm not sharing this notebook because all this code is already present in the segment anything 2 model official repo. You can get this code from there and you can try this. So guys, I hope this video is helpful, and guys, if you like the content of my video, please like, share and subscribe my channel. Thank you for watching.